So, we are trying to see what are the different possible DC links. We have seen monopolar. The second type of DC link is bipolar. So, again I will try to draw a schematic diagram. So, it is not a circuit diagram. So, the schematic diagram is like this. So, a transformer which is shown in the figure and a box with a thyristor actually represents a 12 pulse converter. So, this is on one side. So, there are two sides, one is rectifier, other is inverter. Suppose I say this is the positive terminal and this is the negative terminal, and the current, positive current ID is flowing is in this direction. So, with this polarity of the DC voltage, now can you say which one, the left side is the rectifier or the right side is the rectifier? Yeah, so this is rectifier. So, this is rectifier side and this is inverter. So, at each side we have two 12 pulse converters, and there is a midpoint on the DC side which is grounded. Okay. So, please note we need grounding so that the two conductors are at the same magnitude, same magnitude of the potential with respect to ground. One is positive, other is negative, but the magnitude of the voltage between any of the conductor and ground is same, whether it is positive or negative. Okay. So, that is the idea. Now, sometimes the grounding is provided at both sides. So, it is always not necessary, on rare occasions grounding is provided on both sides. Okay. So, even one side will do, but at least one side has to be grounded. Now, the purpose of grounding on both sides does not mean that current will flow through the ground, though there is a closed path. So, the two 12 pulse converters are operated identically, so that the current ID is flowing only through the two conductors and there is no current through the ground. Okay. Normally, ground current is 0. So, this is what is known as bipolar. There is one more possibility, that is homopolar. Now, these types of links are just mentioned for the sake of completeness. So, we will see that the only one type is actually preferred in practice. So, again I will draw the schematic diagram. So, in the case of homopolar, both conductors are at the same potential with respect to ground, and we saw that having negative potential will result in less corona compared with positive potential. So, both the conductors are at the negative potential. Now, again the left side is rectifier or inverter. It is rectifier. Please note this is different from bipolar. Hope you have noticed that difference between the bipolar and the homopolar links, and this is inverter. Now, this is just an example of homopolar. In fact, what one can have as a general homopolar link is any number of such 12 pulse converters on both sides, of course identical number. If I have, say, instead of 2 12 pulse converters on the rectifier side, I can have 3. So, if I have 3 on the rectifier side, I will also have 3 on the inverter side. So, this is one example where I have 2 12 pulse converters on both sides. Okay. So, when any number of 12 pulse converters are there on both sides, all the conductors are at the negative potential. So, there is a return current. So, suppose this current is, say, ID, okay, and this current is, say, ID. So, normally all are operated identically. So, if this all the conductors carry same current. So, the current that flows through the ground is 2 ID. So, this is actually flowing through the ground. So, sometimes metallic return can also be used. So, there are a few other possible links. I will not get into all the possible links. When even in the among the 3 which we have seen in this course, the most commonly used link is bipolar. Say, bipolar link has some advantages. If you look at bipolar, bipolar does not have any ground current. Please note, there is grounding provided, that's all, but the 2 12 pulse converters are operated identically. So, the currents that flow in the 2 conductors are exactly the same. So, there is no ground current. So, bipolar is used, but monopolar is something. If you look at monopolar, what is monopolar? If you remove one of the 12 pulse converters on both sides, it becomes monopolar. Okay. Then there should be a ground current. Okay, so monopolar is actually used as the initial phase of bipolar. Say suppose we want to build a bipolar, we initially build one system with only one 12 pulse converter on both sides, okay, which will meet the load for now. Maybe after few years more power has to be transferred, then we need one more 12 pulse converter on both sides. So monopolar can be used as an initial stage of bipolar, and bipolar can come into existence once there is load growth, okay, and as the requirement increases. So most commonly used type of link is the bipolar link.